Okay, good afternoon, everyone, and welcome to the Glenn Research Center this afternoon, as we also welcome our administrator, Mr. Jim Bridenstine. I think most of you are very familiar with his background, but I just wanted to remind you a few things just so to refresh your memory. And then I'm sure he's more than welcome to take all of your questions, and we do have the I.O. tool, as you just heard. So we already have quite a few questions on screen that we will bring up at the end, and please feel free to do that or ask live questions as well. We have the microphones ready for that. So Jim was sworn in as NASA's administrator last year in April of 2018, following his nomination by the President and his confirmation by the Senate. Prior to joining NASA, Jim was elected to the U.S. House of Representatives, serving the 1st Congressional District of Oklahoma, where he sat on the Armed Services and on the Science, Space, and Technology committees. He got his start in public service as a naval aviator, flying the E-2C Hawkeye and including combat missions in Iraq and Afghanistan. Following his Hawkeye tour, Jim also transitioned to the F-18 Hornet, where he flew in the Naval Strike and Air Warfare Center, which is the parent command of Top Gun. He later transitioned to the reserves and then served as the executive director of the Tulsa Air and Space Museum and Planetarium in Oklahoma. He's a graduate of Rice University, where he completed a triple major, followed by earning his MBA from Cornell University. It is my honor and privilege to introduce Mr. Jim Bridenstine.
Thank you, Janet, for that great introduction. It's great to be here in Cleveland at the Glenn Research Center. I'm thrilled that so many people wanted to walk through the rain to come hear the administrator give a town hall, or at least maybe ask me questions, yell at me, whatever it is you're interested in doing. It's great to be here. Thank you, Janet, for that great introduction. Just so you guys know, Janet, in my view, is doing a wonderful job. And now you have leading this center not just an astronaut, but a member of the Astronaut Hall of Fame. Congratulations, Janet. So it's great to be here. I'll start just by giving you some of the questions that I've gotten recently. Many of you probably remember a number of months ago, China landed on the far side of the moon with a lander. And of course, we were very excited to see that for the first time in human history. Somebody landing on the far side of the moon. It's never been done before. And I tweeted a congratulatory message. And certainly, I then got called to the House and the Senate to testify as to how we fell so far behind. I just want to be clear. We did not fall behind. And I testified before the Senate that, in fact, just a few months before that event, we landed on the far side as well of Mars. And we did it for the 8th time in human history, that the United States of America is the only country who's ever been able to achieve that. And now we do it with our international partners in a way where we're getting more science and making more discoveries than ever before. But the InSight lander is doing great work right now on the surface of Mars. Curiosity is doing great work on the surface of Mars. But also, a couple of months after the InSight landing, which again was the 8th one in human history, I don't know if I mentioned that. But after the InSight landing, it was just a few short months after that where we had OSIRIS-REx enter orbit around Bennu. First time in human history we've been able to enter orbit around an object that small. And OSIRIS-REx, of course, is not just a satellite, not just a probe. It's, no kidding, a robot. And it's going to go down and it's going to grab a piece of Bennu and bring Bennu back to Earth for the first ever return of an asteroid from deep space. That's an amazing technological achievement. Then, of course, just a few days after that, on January 1st of this year, we had New Horizons fly by Ultima Thule in the Kuiper Belt, 4 billion miles from Earth. And when we flew by Ultima Thule, we didn't really know what we were going to see. But now we know what it is. It's a binary contact, and we're getting more science and information from that probe, New Horizons, than we ever could have anticipated. Remember, New Horizons is the same spacecraft that gave us the beautiful images of Pluto back in 2015. So it went on to another mission, and guess what? It's still available for yet another mission. Just a few short months after that, we had the Crew Dragon dock to the International Space Station. Again, returning, this is going to be the spacecraft, one of 2 spacecraft that will return us to launching American astronauts on American rockets from American soil for the first time since the retirement of the space shuttles back in 2011. So you look at all of these activities and people say, well, they landed on the far side of the moon. It's fantastic, we congratulate them. But we are still moving forward very, very rapidly. And when we think about commercial crew specifically, what are we doing with commercial crew? We are making an effort so that NASA, when it comes to getting access to the International Space Station, NASA is one customer of many customers in a robust marketplace for low Earth orbit. And we want to have numerous providers that are competing on cost and innovation, driving down cost and increasing access to space. Eventually, we want to commercialize low Earth orbit in its entirety. And last Friday, we had an amazing announcement that we are now have the pieces in place for the we want to prove the markets, I should say, for the commercialization of low Earth orbit, and we're going to use the International Space Station to achieve that. Now, why do we want to commercialize low Earth orbit? Because we're going to the moon. And this is not a repeat of Apollo. This time when we go to the moon, we're going to stay. It's sustainable. We're going to go with international partners, and we're going to go with commercial partners. We're going to utilize the resources of the moon. We're going to utilize the water ice so that we can live and work on another world with an intent, ultimately, to go to Mars. The moon is not the destination. The moon is the waypoint. But the moon is a 3-day journey home. We need to learn how to live and work on a world that's a 3-day journey home. Why? We've seen what happens when bad things happen on the way to the moon. Apollo 13, for example, we can make it back. It's 3 days away. If something like that were to happen on the way to Mars, which is only on the same side of the sun as the Earth once every 26 months, the outcome wouldn't be nearly as good. The moon is the proving ground. Mars is the destination. So the question is, how do we build the sustainable architecture at the moon so we can take these capabilities to Mars? Well, we've got an architecture to do that. A lot of it was in place before I ever got to NASA. But now with the new president's directive, the Space Policy Directive 1 to go back to the moon sustainably, we're putting other pieces in place. And of course, we put together a plan to go in 2028. The president and the vice president said that's not good enough, we've got to go faster. We're going to retire the political risk. The political risk is why we're not on the moon right now. In fact, it's why we're not on Mars right now. The political risk is what has prevented us from achieving the end state of sustainable exploration. I should say sustainable human exploration. Make no mistake, we've been exploring all along. But what we have to do is we have to create the environment where we can actually achieve the goal and then stay. And that's what we're doing by accelerating the path to the moon. Instead of 2028, we're moving it up to 2024. The president and the vice president have given us an amendment to the budget request that enables us to go faster so that we can achieve a 2024 landing in phase 1 using the Gateway with new landers that we're going to be developing using the Gateway. But then in phase 2, by 2028, we need sustainability. How are we going to have more access to more parts of the moon than ever before? We want to be able to get to any part of the moon anytime we want as the United States of America and with our international partners. So that's the goal by 2028, and eventually the goal is to retire all of this risk, both technical and political, and take our technologies and our capabilities onto Mars. So we're going to watch a quick video about NASA, we are going to the moon and onto Mars.
50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible.
It's very pretty out here.
Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
and more in testing,
this system is capable of being the catalyst for deep space missions.
we need a capsule
that can support humans from launch
through deep space and return safely back to Earth. For this, we built Orion.
This is NASA's next generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources.
We're currently developing an entirely new approach to landing and operating on the moon. Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and to stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable, that can land anywhere on the lunar surface.
The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits.
It will balance between the Earth and Moon's gravity,
in a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified for water, separating oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
to prepare us and propel us to Mars and beyond.
This is what we are building.
This is what we're training for.
This we can replicate throughout the solar system. This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and on to Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see it with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going. We are going. We're going.
Yay. So we're going to the moon with an eye for Mars. We're going sustainably. We think about what the architecture is. You saw the SLS, you saw the Orion, and you saw the Gateway. Of course, when it comes to the Glenn Research Center in Plum Brook out at Sandusky, we know how important what Glenn is to the mission. We have to be able to test these vehicles in a thermal vacuum chamber. We also have to do all the electromagnetic interference and the electromagnetic compatibility tests. And there is no place on the planet that can do those at all other than Plum Brook. And so we're thrilled to be here at the Glenn Research Center so that we can go forward and do these missions. It's also true that because of the great work of this center, we got the power and propulsion element of the Gateway under contract right now. And the first meeting is happening, did you say this week or next week? This week, Wednesday. So we're moving fast. We're going to the moon. We're going sustainably. We're moving fast. And we're going to take advantage of everything that NASA has to offer. So whether it's the Orion crew capsule and the European service module and testing those vehicles, whether it's doing the power and propulsion element, and of course, the important piece is what do you do when you're on the surface of the moon? We need in situ resource utilization. We need to understand how are we going to get power on the surface of the moon? That's what kilopower is all about. So Glenn is very involved in our activities on the surface of the moon as well. In situ resource utilization. I know there's experiments happening here at Glenn that help us, no kidding, turn the lunar regolith into oxygen, if you can imagine that. Turning oxides into oxygen. Great capability, and of course, what do we do with the water ice? We need to be able to turn it into water able to drink, but also air to breathe, and ultimately rocket fuel, hydrogen and oxygen. All that's available on the moon, and Glenn is going to be very instrumental in helping us achieve these goals for a sustainable lunar return and an eventual mission to Mars. So with that, what I'd like to do now is just open it up to you. Hear what you have to say, understand your thoughts and concerns, certainly ask questions, and I'll be happy to answer any questions that you may have.
If you want to ask questions on here, but also we want to make sure that people who would like to ask questions, who are brave enough, I always challenge people to be brave enough to ask questions in person. If they'd like to do that, they're certainly welcome to do that as well. So if we have any takers, here's a brave one right here in front. So we need one microphone right down here.
Hi, so my question is basically, I look to my leadership for like inspiration and motivation. So I guess I'm curious, what do you look for inspiration, motivation?
I look to you, and I'm being serious. I have the opportunity to lead probably the most impressive agency, not just in our country, but on the planet. You look at what NASA does every day, day in and day out, with the brightest minds and the most capable people, it is astonishing. We're rewriting history books. We're rewriting science books every day here at this agency. And there's no shortage of opportunities for me to put new content into what I talk about in public, because every day new discoveries are being made. So I'm being honest, I look to the folks at NASA. I look to the people that do the amazing work that this agency does, and they encourage me every day to do everything I can to make this a go, and we're working on it.
Thank you. We have one back here.
Are we considering any alternate architectures, such as directly to the moon, as the previous administrator, Mike Griffin, had suggested, as well as Buzz Aldrin, and of course Bob Zubrin, whom we don't always agree with, because he wrote direct to Mars. But on this issue, he said we should go to the lunar surface rather than just to the gateway. And what distance, what's the orbital period of the gateway? Thank you.
So those are all good questions. So when we think about how we get to the moon, we're going to go fast. We want to have the next man and the first woman on the south pole of the moon within 5 years. That's a tall order. So we have to start with what already exists. What exists? SLS exists, Orion exists, the European Service Module exists. Now, we could aggregate a lander and maybe go to the surface of the moon directly. Here's the challenge. If you look at SLS and Orion with the European Service Module, it has enough delta V. It has enough delta V to get to low lunar orbit. But it doesn't have enough delta V to get out of low lunar orbit. That's a problem. So we're going to need more delta V, and you got to get it somewhere. Somewhere, you're going to have to do automatic rendezvous and docking to get more delta V. It just so happens that we had the gateway already concepted. We are under contract now for the first element of the gateway, the power and propulsion element. So the gateway is that extra delta V that we need. So we don't have to start with a clean sheet of paper with brand new rockets, even bigger than SLS, and an upper stage even stronger than the European Service Module. We don't have to start with a blank sheet of paper. That's how we're going to make it possible to land within 5 years. Now, during the course of this, you look at the gateway. The orbital period, I think, is like 7 days. But what we're trying to achieve with the gateway is ultimately sustainability, but it's more than that. So think of a reusable command and service module. We're going to have a command and service module. Think of one that's reusable. In other words, it'll be there for 15 years. And that's going to give us access to the lunar surface from that reusable command and service module. Now the question is, who can build the lander that can go from the gateway down to the surface? The gateway is in what we call a near rectilinear halo orbit. It is distant from the surface of the moon. So some people say you got to have a transfer vehicle to get to low lunar, then you have to have a descent module and then an ascent module. Other people, contractors specifically, say you can go direct from the gateway to the lunar surface and then back to gateway. Here's what we're doing differently when it comes to the lander. We are not writing the requirements and specifying ultimately how you're going to build your lander. We're not going to generate thousands and thousands and thousands of requirements and then put out an RFP, or even before doing an RFP, doing an RFI, and then an RFP, and then getting proposals, and then evaluating the proposals for years, or at least a year, and then putting out an award only to be protested for the next year. Like, that is not the model that will enable us to get to the surface of the moon within 5 years. So how do we go faster? How do we do what was done back in the Apollo era? And of course, they used the traditional contracting model, but they had all kinds of authorities and a whole lot less restrictions and regulations. So how do we use the other transactional authorities to get humans to the moon? We use the gateway. It's already going to be there. We're going to aggregate at the gateway a lander, but we're not purchasing it in the traditional sense. We're going to say to the contractor, here's the requirement. Get our astronauts to the surface of the moon and back to gateway. Yes, we're going to make sure that what you're suggesting is feasible and possible, but we're not going to generate the requirements for you. And by the way, we expect you, the contractor, to put skin in the game. We want you to have your own investment in this project. Why? Because we expect you to get customers that are not NASA. And those other customers could be international, they could be commercial, it could be tourism, it could be people interested in trying to make their own discoveries, whether it's platinum group metals or water ice or whatever it happens to be. They might have customers that are not NASA, and we welcome that. When we think of the gateway architecture, it is open architecture. So the way we do data, and the way we do communications, the way we do avionics, the way we do docking, the way we do life support, all of it is going to be available on the internet. And if you're a small country or a company and you want to have access to the surface of the moon, you can plug into our architecture and we can make it happen. Now, it's not going to be free. You're going to actually have to pay for a service. Part of the service is going to be from NASA. Another part of the service is going to be from a commercial company that can get you to the surface of the moon. But the goal here is sustainability, and at the same time going fast so we can make sure we get there within 5 years. We're not going to get there within 5 years if we're starting with a blank sheet of paper and having to develop all new rockets and all new upper stages and all new service modules. So we need to use what already exists. We need to build sustainability. The Gateway gives us that. The Gateway gives us two other things that are important. Gateway is going to have power and propulsion, solar electric power and propulsion. So that gives us an ability to maneuver. We can get to the L1 point, we can get to the L2 point, we can get to more parts of the moon than ever before and make new discoveries. That's the power of the Gateway. So when we think about 1969, we landed on the moon. Next month we're celebrating 50 years since the Apollo 11 moon landing. 1969, up until 2009, many people believed that the moon was bone dry. Now we know it has hundreds of millions of tons of water ice. Why do we want more access to more parts of the moon than ever before? Because we want to know what else is there. What else have we missed? And that's why we want more access. The Gateway is going to give us that. The other value of the Gateway is this. It's our access to Mars. Now, is the first Gateway going to get us to Mars? No. But we need to prove the technology, prove the capability so that we can get onto Mars. That's the horizon goal. The moon is the waypoint. We need to learn how to live and work on another world. We need to learn how to be there sustainably. We need to have more access to it than ever before. And then we need to take everything that we learn and we need to take it onto Mars. That's why the Gateway is important. Now, if somebody wants to go to the moon commercially and they want to go direct, we're for it. And by the way, we're not saying that down the road we might not buy access to the surface of the moon directly. In fact, right now we're doing the CLIPS missions, Commercial Lunar Payload Services. The CLIPS mission, that was my first initiative when I got to NASA. If we have a 15-pound small payload that we need to get to the surface of the moon quickly, how do we do it? Does NASA go forth and purchase, own, and operate a lander? Or does NASA say, who can build us, who can provide the service to take us to the surface of the moon. That's what the Commercial Lunar Payload Service is all about. And we're going to see maybe as early as next year the first Commercial Lunar Payload Services science instrument land on the surface of the moon. So sustainability, speed, more access than we've ever had to the moon, and ultimately an eye for Mars. You bet.
All right, since you kind of touched on this, I'm going to go to one of the questions here. It's probably the elephant in the room, maybe. On Friday, President Trump said that NASA should not be talking about going to the moon. Does his comment indicate a shift in the White House's support for Artemis?
No, not at all. So here's the thing. Remember what happened on Friday. We went to Wall Street, and the chief financial officer of NASA rang the closing bell for the new commercialization of low Earth orbit. It was a pretty exciting day. And then he went on a business news program, and he got we'll just say that the news guy on the other end started arguing about why go to the moon. We've been to the moon. Why go to the moon? And it ended up getting bogged down in this argument about whether or not the moon is valuable, which is quite frankly not where we want to be. The moon is valuable because it's a proving ground for how to get to Mars. And that's exactly the case that the president made. And if you read his tweet, he talks about going to Mars, and he says in parentheses that the moon is a part of that. In other words, we're going to the moon in order to get to Mars. Nothing has changed. Some people have tried to read more into this than there is, but here's the thing. We're going to Mars. The moon is a waypoint. We need to learn how to live and work on another world. The moon is a 3-day journey home. You don't want to do that when your journey home is 2 years from now. That can't work. So yes, we're going to Mars. The moon is the way to get there, and we've got a lot of very exciting activities going on Mars right now. So nothing has changed. The program is the same. We're going to the moon to get to Mars.
Excellent. Anyone in the room have another another question before we go to the tool again? All right. Oh, yes, we do. Right here in the center.
My question is, what's the status of the budget with Congress regarding the Moon to Mars mission?
That's a great question. So this is important because, and I know people have heard me talk about this before. There's two types of risk. There's a reason we're not on the moon right now. There's a reason we're not on Mars right now. Two types of risk. One is technical. People in this room have amazing capability to retire the technical risk. The other is political. So one of the things I advocated strong for in this amended budget request is that when we get the money to accelerate the path to the moon, that it not cannibalize the Science Mission Directorate and it not cannibalize the International Space Station. Because if you do those things, if you cannibalize science, you're going to create a partisan fight, you're going to create a parochial fight, different regions of the country. If you try to take money from the International Space Station, you're going to have the Texas delegations and the Florida and Alabama delegations upset. That's a non-starter as well. We look back at the history. The Space Exploration Initiative of the 1990s resulted in nothing. Why? Because of the political risk. It was too expensive, and ultimately Congress never went along with it. The vision for space exploration of the early 2000s, it ultimately ended up taking money from the Science Mission Directorate. That also is a non-starter. So how do we get to the end state, which is the next man and the first woman on the south pole of the moon within 5 years? We've got to make sure that we're understanding the lessons of history and moving forward. So we got the $1.6 billion new dollars. $1 billion of that is focused on the landers that will get us to the surface of the moon. And then another big chunk of that is ultimately focused on the SLS rocket and Gateway. So we get those things complete, that gives us the access to the surface of the moon. Now, all of that is done within OMB, who we worked with very closely to get this amendment. But that's not where our money comes from. Our money comes from the appropriators in the House and the Senate. By the time we got the budget over to the House, it was the same week they were marking up the Commerce, Justice, Science Appropriations Bill, which is what funds NASA. So for those who don't know, that bill, if it was being marked up that week, that bill had been cooked for a long time. So the idea that we were going to put it on the House to pass our amendment the week they were marking up their bill, it just wasn't in the cards. The media read that as, oh, well, look, the House doesn't support the project. That is absolutely not true. I think what it does is it shows we were late to the game getting it over there. Ultimately, the House or the Senate has not yet marked up their bill. So the Commerce, Justice, Science Appropriations Bill in the Senate, I think, is in good shape. In fact, after we got the amendment over, we got a tweet from Senator Moran from Kansas, who chairs the CJS, Commerce, Justice, Science Appropriations Committee in the Senate, and he sent out a tweet, and he said he will work with, at Jim Bridenstine, he tweeted at me, to make certain, that we have the resources necessary to land the first woman on the moon. So that is, I think, a very positive step. Ultimately, the House will pass a bill. They've already done that. The Senate will pass a bill. They're working on it. When those two bills don't agree, there will be a conference committee, and that's where what happens matters. So we're working to make sure that when that conference report comes out, it's favorable towards the $1.6 billion additional dollars, namely for the lander that can get us to the surface of the moon. So that's where it stands. I think we're okay. I'll tell you another big risk is that we could end up in a CR at the end of the year. So to the extent that we end up in a CR, that sets us back. But there's ways that we can work through that as well. But I'll just leave it where it is right now.
Okay. A question back here in the center.
So when it comes to trying to make like some of the hard decisions about what capabilities to take with you and what do you need on the moon or what do you need in this particular place, a lot of times those decisions get made through what are your primary objectives. So I can think of a ton of really great like primary objectives, and you've talked about a lot of them: economic, strategic, science objectives. What do you see, like, so when I talk to my grandma about like why are we doing this, right?
Yeah.
What are kind of like the big picture like primary objectives that you see of us going to the moon first? Like what are the economic, where do you see those kind of bright lines as to why are we going and what is the main objective, so that we can kind of make those priority decisions as we go down the line? Like, do we need this capability? Do we need this sensor? Do we need this thing?
That's a wonderful point. And I'll tell you, if we went around this room, and we've done this exercise at headquarters, if we go around this room and we say, do you believe we should go to the moon? Do you believe we should go to Mars? The answer will be yes to both. Then you ask, why? You will get a different answer for every person in the room. And I think that's actually a very good thing. We don't want to boil it down to one reason, because if you do that, then you'll exclude all the other people who want to go for their own reasons. But I'll tell you where we start. In my view, we start with the science. Again, we learned in 2009 for the first time that the moon has water ice. Who knew? Some people say they suspected, but nobody knew. Now we know hundreds of millions of tons of water ice. What else do we not know? The lunar surface is a repository of the ancient history of the solar system. The Earth is not. Why? Because we have this very active geology. We have a magnetosphere that prevents charged particles from hitting the Earth. We have an active hydrosphere. We have the atmosphere, and all of this stuff is constantly changing and moving. So anything that hit the Earth billions of years ago isn't today where it was billions of years ago. The moon is just the opposite. Doesn't have an active geology. Doesn't have an active hydrosphere. Doesn't have an active atmosphere. Although today in the VITS, leadership was talking about that there actually is a trace atmosphere at the moon, which is fascinating to me. And by the way, there's a water cycle on the moon. Guess what? When charged particles from the sun interact with the lunar regolith, that's how the water ice gets created. Also, asteroid impacts from billions of years ago results in water ice. And when those impacts occur, the water gets spread out, and somehow it all ends up ending at the poles of the moon. Another fascinating kind of piece of information regarding the water cycle. Anyway, here's the point. Whether it's asteroid impacts from billions of years ago, or it's charged particles from the sun, also from billions of years ago, the lunar regolith is a repository for the history of the early solar system, because it doesn't have that active geology, hydrosphere, water cycle. It doesn't have all those things. So the science is where we start. I would also say, when you think about the science of Mars, we know that Mars had an ocean in its northern hemisphere that covered 2/3 of the northern hemisphere. We know that it had a strong magnetosphere and it had a thick atmosphere. In other words, Mars at one time in history, it was habitable. Not saying it was inhabited, but it was habitable. And we know that all of that changed at one point in the past. And what caused it to change? Did the core cool? That's why we've got InSight on Mars right now, trying to understand the inside of Mars. Interestingly, just since I've been the NASA administrator, we've discovered complex organic compounds on the surface of Mars. In other words, the building blocks for life exist on Mars. So we know Mars was at one time habitable. We now know that there's complex organic compounds. That doesn't exist on the moon. None of that information exists on the moon. But it's on Mars. Then you think about the fact that the methane cycles of Mars are perfectly commensurate with the seasons of Mars. That's amazing in itself as well. The probability for discovering life just went up. Now we know that underneath the surface of Mars, 12 kilometers is liquid water. What do we know about liquid water on Earth? Anywhere it exists, there's life. So all of these discoveries, and those last three, complex organic compounds, the methane cycles, and the liquid water were made in the last year. That's amazing. And the question is, what else do we not know? So I would argue that one of the greatest reasons we need to go to the moon and onto Mars is for the science. I think if we find life on a world that's not our own, it's going to be transformative. A lot of people are going to be very interested in exploring space more than ever before. But the science is just a piece of it. I'll tell you another thing that I think is important. You look at all the countries around the world right now that have a mission to the moon. The European Space Agency, Canada has teamed up with Japan and the European Space Agency for another mission to the moon. Russia has a mission to the moon. China has many missions to the moon. In fact, as I just mentioned, they landed on the far side of the moon. Now they're going to do a lunar return mission. Israel has a mission to the moon. Did I mention India? There's all these different countries that have missions to the moon. The question is why? And the question is who's leading them? Well, they're all doing it on their own. I think it's important that the United States of America lead. And not just lead with these robotic missions to make these small discoveries, but no kidding, lead with a sustainable return to the moon with our eyes on how do we live and work on another world so we can go on to Mars. That's what we ought to be doing. And to the extent that you look at what the United States of America has done in low Earth orbit with the International Space Station, we've got 15 nations that operate the International Space Station. The United States of America brings the preponderance of the resources and assets to the International Space Station. That is absolutely true. But ultimately, it is a tool of not just amazing science and discovery, a tool that enables us to know how we're going to study space, deep space, for longer duration missions, but it's also a tool of diplomacy, a tool of American leadership. And of course, extending what we've learned on the International Space Station from a diplomatic perspective, and extending that to the Gateway and to the lunar surface and onto Mars, and not just going with 15 nations, but going with even more nations, with the United States of America leading with this open architecture that enables everybody to do more. This is what we do as a country. This is how we lead. And that's what we ought to be doing, is leading. Then when you think about the resources, we're going to utilize the resources of the moon. What is of value there? We talk about platinum group metals. We know we have these rare earth metals on Earth. They're not Earth metals. They're asteroid impacts from billions of years ago, but they're not where they used to be, and to the extent you find them, they're in trace amounts. Well, the moon and the Earth, we go through the same piece of space all the time. We're always together. So the question is, are there much larger volumes of rare earth metals on the moon? Although they wouldn't be rare earth metals, they'd be rare lunar metals. So these, I think, are other important questions. But I think the science is overwhelming. The resources is important. International leadership, I think, is a key piece. And then the commercial activities where there's going to be large investments from private companies coming into this. I think all of those things position us as a country to lead. And I think it would be a shame if somebody else led in this effort. I will also say, gosh, this is more than you ever wanted to know. But you've heard me probably say it before. I'm going to keep saying it. You look at what resulted from Apollo. We're putting this on NASA TV. Who watches NASA TV? People who get their TV on satellite. That's who gets NASA TV. So Dish Network, DirecTV. We talk about internet broadband. Internet broadband from space. I come from Oklahoma. A lot of Oklahomans, if you don't have broadband from space, you don't have the internet. It's just the way it is. So you look at how we communicate, XM radio. NASA has transformed communications for all time, giving people access and connectivity that never would have otherwise had it. Now, did we go to the moon for that purpose? No. But did it happen? Yes. But it's not just communication, it's navigation. NASA, of course, we were the principal investigator into creating the technologies for GPS. Communication, navigation, producing food. Right now, we're reducing water usage and producing higher crop yields than ever before, preserving nitrates in the soil because of NASA technology. By the way, that's the same technology that we use to map the surface of other planets. And now we're applying it to our own crop capabilities here on Earth to feed more of the world than ever before. Did NASA do that for that purpose? No, but it's a capability that is elevating the human condition. The way we produce food, the way we produce energy cleanly, the way we do national security and defense, the way we understand the weather. You know, we can predict the rain that we're seeing today 7 days ahead because of NASA technology. NASA builds all of the satellites that NOAA uses for the National Weather Service. And of course, the way we understand climate. All of these things are technologies and capabilities born, quite frankly, all the way back to the Apollo era. And of course, now our budget is less than 0.5% of the federal budget. So the question is, what do we get by going to the moon and onto Mars? I can tell you, even without knowing the future, it's massive. And if you ask the Apollo astronauts, you know, what are we going to get by going to the moon? Would they have told you communication, navigation, producing food, producing energy, national security, defense, understanding the climate, understanding the weather, predicting? Would they have told you all those things? No. But you know, what I hear about is Velcro. I hear about Tang. So, but my point is this: for less than 0.5% of the federal budget, we have transformed the human condition in a way that is immeasurable. And how do you put that into a nutshell? All you can say is the return on investment is so big it's immeasurable. There is nothing like it. Any dollar that the United States of America spends on NASA is a dollar that returns many, many, many times. Immeasurable. It's a great question.
You guys are doing a good job. Anybody have another question out there? Okay, one over here.
Good afternoon. The engineering professional societies, and for example, the Aerospace Division of the American Society of Civil Engineers, which I and the Center have been heavily involved with, have been looking at a lot of these issues in situ resource utilization, space engineering, space construction, exploration and utilization of extraterrestrial bodies, have been looking at and dealing with these issues for a long time. As you start to move into some of these areas, have you given any thought of the potential of reaching out to some of the relevant committees and divisions of the professional societies to interact with them and to pull upon some of the expertise resident within the participants in these organizations?
So at this point, I have not done that yet. But I'll tell you what, that's a great idea, and I would love to do it. I'll tell you, right, I'm worried about the closest alligator to the canoe right now. My closest alligator to the canoe is, now that we've got a budget request with an additional $1.6 billion, how do we make that happen? But to the extent that you've identified, we need to reach out to those organizations and get their feedback. I'm happy to do that. I would imagine our center director here and others would be happy to do that as well.
Yeah, in fact, we talked about the Glenn Symposium later this summer on July 11th and 12th, 10th, 11th, and 12th, and we are inviting and engaging, I think, some of those societies as part of that symposium. So we will be touching on those topics at that symposium.
That's awesome.
Thank you.
Thank you. Great point.
Anybody else? All right. Good job.
Since a significant portion is contracted out, what do you see as NASA's engineering role on the missions going forward?
So that's a great question. Number one, we have a lot of programs underway right now. And those programs that are underway are going to continue moving forward. And all of the NASA expertise and technology experts and engineers are going to continue doing what they're continuing to do. The question is, when we start accelerating the path to the moon and we need to get more capability faster, do we plus up the civil servant workforce, or do we buy the service to get to the surface of the moon? And those are difficult challenges. I would argue that we can buy access from the gateway to the surface of the moon from commercial industry, and we can use the talent that we already have to embed with commercial industry to make sure that what they're doing is going to achieve the goals that we're looking for. So rather than us creating all of the requirements and going through the whole acquisition process and getting all of the 50-pound heads involved, which I'm sure you are among, and that's a compliment, by the way. That means you're a smart guy, as pretty much everybody at NASA is. Instead of starting that process in that way, we take the engineers and the technologists and the scientists that we need, and we embed them in the projects with our contractors. I think that's how it'll be.
Okay, thank you.
You bet.
You sort of touched on this, so I'm going to go onto this question here. It says, we're talking about contracting out. Why are we spending $2 billion per year on the SLS when SpaceX is building a rocket with similar capability for little or no cost to NASA? Wouldn't it be a better use of our resources to start working on something else like the lunar lander?
It's a good question. So SLS is it's the hardware is being built right now. You can look at it. The intertank has now combined the hydrogen tank and the oxygen tank, and it is in full production mode. I think it's important that if we're going to get to the moon within 5 years, we need to use technology that currently exists. We need to use capability that exists right now. What we don't want to do is start with a clean sheet of paper, believing that rockets are going to be developed within 5 years that are going to take us to the moon. Rockets that don't yet exist, existing within 5 years, I think is a bit of a stretch. I'm not against it. I think it's a good idea, but it's not going to help us get there by the year 2024. So I think the best course of action is to go forward with the hardware that already exists.
Okay. No one else? Let's see. You've been adamant that NASA should not redirect funding from existing programs and other directorates to fund human exploration of the moon. However, the budget amendment the administration submitted to Congress proposes to give you authority to transfer funds among NASA appropriations as necessary to establish a presence on the moon. Could you explain what this provision entails and how you plan to use it?
Another great question. So I want to be clear. I wanted to have transfer authority so we could move money from here to there without being constrained in order to accelerate the path to the moon. Because we know this. Some parts of the project are actually going to get hung up, and we're going to need more resources for them. And if we have to go through a big bureaucratic effort and get Congress to agree to certain things at the time and go through process after process after process, the long lead items end up being longer lead items. We don't want that. We want to put resources where they need to be right now to get the job done. That being said, it was never my intent that we were going to take money from the Science Mission Directorate and reroute that over to the Human Exploration and Operations Mission Directorate. And anybody who has heard me talk over the last year knows that that is not my intent. In fact, I've been a strong advocate for not cannibalizing the Science Mission Directorate in order to fund the Human Exploration and Operations Mission Directorate. Why? Because it results in a political fight that makes the end state unachievable. So I've been a strong advocate for not cannibalizing science in order to fund HEO. I will also say that within HEO, that's what I'm looking for the transfer authority for. So that if one piece of the architecture is having challenges and another piece of the architecture is doing really well, ahead of schedule, below cost, then we can transfer funds from that piece of the architecture to the other piece of the architecture. That's what that's about. Now, I got people from Congress telling me that maybe I was trying to take money from science. Not true. I've said it over and over again. That is not my intent. And if Congress wants to carve out that you can't take money from science, I'm for it. Why? It takes it off the table. It's not an issue. Never was, never will be. So I think that's the question that they were asking.
Okay. Anybody else? All right. I know you wanted to hit in on this one. It was a little bit out of order, but do you foresee harvesting lunar resources with and through commercial partners to violate the Outer Space Treaty?
No. It's a good question. I've had this a lot, to be honest. So the Outer Space Treaty says very clearly that you cannot appropriate the moon for national sovereignty. That's what the Outer Space Treaty says. Now, people have said, well, that means you can't use the resources of the moon. I disagree. And in fact, when I was in the House of Representatives, we did the Commercial Space Launch Competitiveness Act in the House, and I put an amendment in there that said that you could utilize the resources of the moon if you can extract it. You, in essence, tie your labor, your investment to those resources. Those resources become yours. That does not mean you have appropriated the moon for national sovereignty. It just means you have the rights to those resources if you put forth your investment and put forth your labor in acquiring those resources. Now, we put that in the Commercial Space Launch Competitiveness Act, and it passed with bipartisan support in the House. It went over to the Senate, and it passed. They changed the name of the bill. I think it was called the Space Act in the Senate. It passed with strong bipartisan support. That bill went to President Obama's desk for signature, and he signed it. So that is a strong bipartisan consensus that if you put forth the investment and the labor to get resources, whether it's from the moon or other celestial bodies, you have the rights to those resources. And I think that's a very positive development. It is not appropriating the moon for national sovereignty.
Okay. Any other questions? I think maybe we could, yeah, you do, okay. We have one down here, Mike. We have about 4 minutes left just for a
to that last question, I do think it's important that the Outer Space Treaty, it's written in a way that's very broad because it was a consensus treaty, and I don't know how many countries are signatories to it, but I think it's over 100. At the end of the day, it's a treaty on principles, and so it's up to us to define how we interpret those principles. And the United States Congress, in bipartisan fashion, with the support of President Obama, interpreted that. And we interpreted the Outer Space Treaty for the United States of America, which is what our legal obligation is. And we did it. I think it worked. It's a good process.
First of all, let me thank you for your continued demonstration of excellence in leadership, both politically and technically, by the way. So thank you for that.
Thank you very much.
You mentioned our international partners. I wondered if you might share some of your thoughts on the balance of the political risk in terms of shooting for 24, but also trying to involve them.
Very important point. So the way we describe this is 2 phases. Phase 1 is about getting to the surface of the moon as soon as possible. So we talk about the minimum gateway, power and propulsion element, and a mini HAB. We want that in orbit of the moon, near rectilinear halo orbit by the year 2024, and we want to have a lander that will be aggregated at that mini gateway by the year 2024. Now, one of the things that people have said is, well, does that exclude international partners? Well, no. If there is an international partner out there that wants to produce, for example, Canada. By the way, great story. Canada is with us now on Gateway and at the moon for 24 years. That is unheard of. To get a commitment from a country like Canada that's 24 years in duration is unbelievable. Normally, they'll do things in 4-year chunks, at the most 8-year chunks. It's never been done in Canada where they commit to a program like this for 24 years with a Canada arm, which is critically important. Now, if they want to deliver that ahead of the 2024 date, we'll be ready for it. We can accept it. If there's another country out there that wants to build a habitation module that we've agreed to, which we haven't yet, but we could. They want to build a bigger habitation module and they want to deliver it before 2024. We've got to make a determination. Is it going to help us get to the moon in 2024? And if not, maybe we wait until after that 5-year window is complete. But at the end of the day, here's the important thing. Phase 1 is about speed. It's about getting to the surface of the moon. And phase 2, and by the way, international partners are welcome to join us in that. If there's opportunities for them, we welcome them. Phase 2 is all about sustainability. From 2024 to 2028, how do we make the Gateway a sustainable destination for longer periods of time? And how do we make it give us more access to science on the moon, deep space science, science on the gateway itself as a microgravity kind of module. So all of these things, I think, are in the trade space. The first priority is to land the first woman and the next man on the moon in 2024. The next priority is to build the sustainable architecture. That's where we're going to lean heavily on international partners. By the way, that architecture includes lunar surface habitation. How do we stay on the surface of the moon for longer periods of time? So all of that is in the trade space. But we have been very clear with our international partners. We need them. We want them. This is not just an America-only approach. This is us leading a coalition of nations for a sustainable return to the moon and then on to Mars. Yep, thank you.
Thank you. And we're very nearly out of time, so we wanted to thank you for your time here. And if you had any final closing remarks.
I'll close it out.
Yes.
Thank you, Janet, for giving me this opportunity. Thank you all for being here. Last thing I'll leave you with is this. Next month, we're going to be celebrating 50 years of Apollo. 50 years since we landed on the moon. The Apollo program is something we're all very proud of. It really changed the course of history, not just from a scientific and technological perspective, but it changed the course of history from a geopolitical perspective. It was a contest of political wills, political ideas. It was a contest of economic prowess, political prowess, and also technological prowess. And the United States of America was able to land on the surface of the moon July 20th, 1969. Something all of us are very proud of. Here's the thing. In those days, all of the astronauts came from a fighter pilot background or a test pilot background, and there were 0 opportunities for women in those days. Now, it just so happens that Apollo, who's a god in Greek mythology, had a twin sister named Artemis. Artemis was the twin sister of Apollo, and Artemis happens to be the goddess of the moon. 50 years after Apollo, we have a new generation. Many of you remember exactly where you were when we landed on the surface of the moon, July 20th, 1969. I will tell you, I do not have that memory. I was not around. Others of you in this room were not around. This is our generation. This is our moment. We are, in fact, the Artemis generation. We need to make this thing a reality because we can't have yet another generation go by without having experienced this deep space exploration of another planetary body, namely the moon and onto Mars. This is our generation. This is our moment. This is our time. And now, under the Artemis program, the twin sister of Apollo, we have this very diverse and very talented astronaut corps where we have an opportunity to send not just the next man, but the first woman to the moon. And not just to the moon, but the south pole of the moon, where we now know that there's hundreds of millions of tons of water ice. We can do it in a sustainable architecture. We can do it with an eye for Mars. That's what the Artemis program is all about. So I want to encourage you to think of yourselves differently. You are not just working on the Artemis program. You are the Artemis generation. I want my 11-year-old daughter to see herself as having every opportunity I saw myself as having when I was 11 years old. That means we need to take this very diverse, very qualified astronaut corps and go back to the moon sustainably. Learn how to live and work on another world and go on to Mars. We are the Artemis generation. Make sure you're communicating that to all of your friends, all of your relatives. This is our moment. This is our time. We're at a unique point in history where we have an opportunity to make this a reality. So I just want to say ahead of time, thank you for all of your work. Keep it up. Go forward and do great things. And I'll look forward to coming back and seeing what next items you guys have accomplished. So thank you so much.